Hey guys, so in this one we are looking at hopefully something we've seen before at GCSE, just in a slightly different place. So, set notation with inequalities. So, let's have a quick recap on the set notation. So that's when we either use this guy or the guy that looks like an N. So this guy that looks like a capital U is a union, but we can think of it as saying or. So, for example, if we had written down A union B like that, that means A or B in normal speak. Or, if we had the upside down one that looks like an N, this guy is the intersection, which we can think of as saying and. So, if we have A intersection B, we can think of that as A and B. So, we can apply this stuff to solutions of inequalities. Now, as we get into this video, you're probably going to be thinking, oh, what's the point in this? It makes things a bit more complicated, to which I completely agree. But we need to know it, we need to be able to read it. It's like learning a different language. We might not agree with it, but we need to be able to do it. So, there is one more thing we're going to need, and that is what I call posh brackets. So, brackets that look like this. So, I'm just going to say here and now, I'm crap at drawing these, so I apologise for the state of my brackets as we go through. So, this video, I'm just introducing the notation. So I'm going to give you examples of inequalities. We're not solving them. So examples of solutions. Then I'm going to write them in set notation, which is going to pop up in the videos where we're looking at solving them too. But I figure it's probably good just to introduce it. First of all, as its own thing, try and get you guys understanding it before we apply it. So, let's get cracking. Okay, so our first example here, a nice simple one, we got x is greater than 3. So, how do we write that in set notation? Well, first of all, we need our posh bracket. Something like that then, x with a colon. So far we read that as x is such that, and now we just put that inequality. So x is greater than minus 3, like that, and then close the bracket. So that whole thing in the set notation there, we read that as x is such that x is greater than minus 3. Good times. Example 2. X is less than or equal to 10. So again, a nice simple one. So in set notation, let's get our bracket out. X, colon, and then just the inequality. X is less than or equal to 10. Okay, so we read that as x is such that x is less than or equal to 10. Okay, third example. So, we've got x is greater than minus 1, but less than 9. So, these get a little bit trickier now. We can't write this as a single inequality in set notation. We want to write it as two single inequalities using set notation. So, what's the first one telling us? We got just this bit tells us that x is greater than minus 1. So, we could write that first bit as x is such that x is greater than minus 1, close that, like that. Now, what are all the numbers inside of this interval? They are greater than -1, but they are less than 9. So they have to be greater than -1 and less than 9. So here, we use an intersection, like that, and then we put the other inequality in. So we're now dealing with this bit. So we got x is such that x is less than 9, like that. So we read that as x is such that x is greater than -1 and x is such that x is less than 9. Okay, next up we have x is greater than or equal to -4 but less than or equal to +4. So in set notation, this is x is such that x is greater than or equal to -4, and so intersection, look at that bracket, like I said, and x is such that x is less than or equal to +4, like that. Good times. Or we can have ones where we've got two separate inequalities. So here we've got x is less than -1 and x is greater than 2. Now these two inequalities are exhaustive. X cannot be both things at the same time. So this is the type of question where we use the union. So in set notation, this is going to be x is such that x is less than -1, or so union x is such that x is greater than 2. And then we got one final example where we've got x is greater than or equal to 0, or x is less than -10. So in set notation, we can say x is such that x is less than -10, or so union x is such that x is greater than or equal to 0. Good times. Okay guys, hope that's made sense. Up next we'll be looking at solving inequalities, and we're checking some set notation too, for good measure.